Okay, thank you very much, and hello everybody, good afternoon. My colleague Paul Holford and I have worked for many years now on what we in Indonesia you call CVPD in citrus. We've often wondered whether a particular ant known as the weaver ant can be used to suppress incidence of the disease and its vector, and this paper is about that. CVPD in Indonesia is the Indonesian name given to the severe Asian form of a devastating and incurable citrus disease known internationally as Pongling. It's associated, as Paul said this morning, with a flow-limited pathogen, Candidatus Liberibacter asiaticus, and it is transmitted by the Asiatic citrus Diphrina citri. The first record of the disease in Indonesia was in Pasar Minggu near Jakarta in 1948. The disease was probably introduced on Siam mandarin trees from southern China. At that point, Pasar Minggu was the centre of distribution of citrus nursery tree stocks in Indonesia. Citrus trees should be CLAS-free when they are planted, because if they're not, they will succumb very quickly to the disease. And even if they are disease-free, spread of the pathogen by the psyllid in the field occurs very quickly, and initially pathogen-free trees can succumb quite quickly to infection. Lifespans of infected trees can be limited to a few years, and this leads to cycles of planting and production losses evident in national production statistics in Indonesia and elsewhere. Infected trees may not bear fruit. Marcotting leads to more rapid loss of trees and should not be used. The pathogen appears to have originated in South Asia in association with a citrus relative. It's been hypothesized that it may have evolved on the Indian plate following the breakup of Gondwana. However, we now consider that it may have evolved in Northeast Africa or in Arabia during intervals when environmental conditions favoured speciation and dispersal of citrus relatives associated with Liberibacters in Africa. Symptoms of this Asian form of the disease were first recorded in the Punjab by entomologists describing impacts of the psyllid. I won't go into these symptoms, but these symptoms are the most accurate published at the time. It's widely reported that the disease started in China. It's more recently said it started in Taiwan. None of that is true. This is a gross misrepresentation of what actually occurred. The disease is from South Asia. The psyllid was described in Taiwan in 1907, but however was first recorded in Java in 1900. In the absence of the disease, the psyllid is a minor pest. It is native to South Asia, as is the disease, we think. The initial spread from South Asia to East and Southeast Asia appears to be connected with colonial activities, particularly the Dutch, as they moved lemon seedlings from India to Indonesia to plant them there in order to prevent scurvy, to get fruit in order to address scurvy among sailors. So we can probably blame the Dutch for the spread of the disease and the psyllid. Use of synthetic pesticides to suppress populations of the psyllid and to slow the spread of the disease is often excessive, very excessive, and it is of limited effectiveness. It doesn't work and it is not sustainable. Such heavy reliance on synthetic pesticides since the 1970s has reduced the effectiveness of natural enemies, including parasitoids, lacewings, ladybirds, and the ant, Oechophylla Smaragdina. Oechophylla Smaragdina was the first insect used for biological control. It was used to control large insect pests some 1,700 years ago on citrus near Hanoi in northern Vietnam. It was cultured in orchards, and bamboo poles were used to enhance its movement between trees. More recently, electrical wires, etc., have been used to enhance movement between trees. The ant reduces economic losses. This is well documented, reduces economic losses Most importantly, in context of citrus in Asia, weaver ant activity is associated with low incidence of the psyllid and of HLB in citrus orchards in southern China and in Vietnam. Professor Cook and her colleagues in Vietnam have reported field observations on the incidence of the psyllid and the disease in orchards in the Mekong Delta. They also reported some laboratory experiments with the psyllid. When the ant is present, symptoms of the disease in the orchards can be up to over 90% lower than in orchards where the ant does not occur. If you look at the second column from the right there, you can see where the ants, where pesticide sprays were common, ants were negligible. The symptoms were 4.3 on their rating, whereas when the ant was common, the incidence was very, very low, about a 95% difference. Likewise, when it comes to the psyllid in the orchards, when the ant was active on trees, psyllid populations on the trees were markedly lower. Impacts of the ant on the disease and the psyllid were attributed to predation or reduced oviposition by psyllid females. Some eggs, apparently, of the psyllid were taken to ant nests. In the laboratory, when ants were released into a cage with eggs and first and second instars of the psyllid, there was over a 60%, over a 50% decline within 24 hours of the ant being released into the cages. That's of the psyllid eggs, nymphs, and first and second instars. Although the ant feeds on honeydew produced by aphids and other honeydew-producing insects, the risk of these honeydew-producing insects of becoming serious pests in the orchards is minimal. Use of the ant is compatible with biological control by other natural enemies and with mineral oils in integrated pest management programs. In Indonesia, the potential for using mineral oils remains to be explored fully. Risks of being bitten by the ant can be reduced. It is an issue. People get scared of the ant. They can be reduced by enticing it out of orchards when access to trees is required and through the application of wood ash to arms and legs. So a fairly easy thing to do. We think that the impacts of the ant or use of the ant to suppress incidence of ACP and HLB should be further investigated. Susceptibilities of all life cycle stages of the psyllid to predation need to be determined, as do any possible repellent effects of the secretions of the ant on the psyllid, as indicated by the studies in Vietnam. We believe that historical practices dating back more than 1700 years should be relearned and adapted to contemporary orchard management practices. Possibly, they may be more suitable for small orchards than larger orchards. Commercial rearing and release of the ants should be evaluated in natural populations we believe should be protected from overexploitation. These, in my paper and here, there are some videos and links, and these videos are very worthwhile viewing and reading. And that's all. Thank you very much.